Today we are going to be doing this Leetcode problem is graph bipartite, right? So let's read the description. So there is an undirected graph with n nodes where each node is numbered between 0 and n minus 1, and we have a 2D array where graph use an array of nodes, and we have given an adjacent node more formally in this undirected graph. I mean basic graph formalities, whatever we have in the question. But the thing is, we have to tell if the graph is bipartite or not. And if a graph is bipartite, if the nodes can be partitioned into two independent sets, A and B, such that every edge in the graph connects a node in set A and a node in set B. Well, let me draw this graph and tell you what exactly it means. So let's say we have this 0, and we have 1, and we have 2, and we have 3, and again these are connected. So we have to divide this graph in such a way into two sets of A and B, where if we partition both of the set in divide, then every edge in the graph in the node set A should connect B, right? And should not connect itself. And I like to think of it as that. I've written also. So I think this question as a graph coloring question, right? So basically, we have, let's say we have two colors. In this scenario, I'm gonna say I have a yellow color and a blue color, right? Yellow and a blue color. Yellow, blue color, right? So let's say, so I have a yellow and blue color, and if I can color all the nodes in the graph such that no two color can be adjacent color can be same. What I'm telling you is, let's say if I have yellow and blue color, right? So let's say if I color this yellow, right, then I color this blue, right, then I color this yellow, right, then I color this blue. So if you see these adjacent, right, them, they have different color, they have different color, they have different color, they have different color, but these doesn't have different color, right? So no matter how we color them, you can also reverse the coloring, like you can also color this blue, right, and then color this yellow, then hence this is an adjacent, I'm going to color it blue, right? Since this is an adjacent, I'm going to color it yellow. Even though if you see these two still have the same color, and we don't want that. We want that every adjacent node in the graph should be colored with a different color if we have two colors, say, right? So that is our question. Let me with another example let you explain what I mean. So let's say in this 0, 1, 2, 3, right? In this case, let's say if I color this yellow, and I color this blue, then I color this yellow, and I color this blue, what you can see is every adjacent node has different color. So if we do divide this particular graph into two different sets, that is A and B, and let's say A is the yellow color one, so we have 0, 2, and B we have 3, 1. So as the statement suggests, a graph is bipartite if the nodes can be partitioned into two independent set A and B such that every edge in the graph connects a node in set A and a node in set B. That means these two nodes should be connected. So 0 is connected to 3, right? It is. And 0 is connected to 1. It is. correct. Then 2 is connected to 3, 2 is connected to 3, correct. Then 2 is connected to 1, is it? Yes, it is. So this checks our condition. Hence this particular graph is bipartite, right? So let's say how exactly we'll solve this, right? I have already written the code and I'll explain you with the diagram of how we're gonna see that. So let's forget this above function. I'll later on I'll tell you why exactly did I write that, and let's go on with the helper class, right? So basically we are going to be using BFS, right? And we are going calling our helper class, right? Let's say our helper gets called, right? Our helper gets called with a graph, adjacency, and a color, and start node 0, right? So what we're going to do is, as you can see, we're going to make a queue. Since we are using BFS, we're going to add that current node to our start index, to our queue, right? And we're going to color that. Initially we can color, since this is our first node, this is the first node that is not being seen, so let's color it any color we want. So right, so let's take this example exactly. 0 1 1 2 and 3. Let's say we are at 0th index, right? And we came here and we're going to color it 0, okay? And for our simplicity, 0 1 0 is blue, 1 is yellow, right? So I'm gonna start coloring the 0 and putting it in the queue, right? And while my queue is not empty, let's pop the current node. So in our queue I have currently 0, right? And I have another color matrix, color array, 0 1 2 3. In 0 we have already colored it blue, right? We have already covered it blue, right? And here I'm popping this one, I'm polling this one current node, right? So let's pop out 0, and in current color what we'll have is 0, right? So then we're gonna traverse all its adjacent nodes, right? And we'll only add the adjacent node if they are not colored in our current queue. So initially we have initialized this color array with -1, you see, right? -1 means it has not been colored yet, and it also acts as our visited array basically, right? So basically if it's not visited, it has not been colored, add it into our queue. And if since the color is always alternate, so whichever node, since whatever we are inside adjacency list, right, of this current node, so whatever this current color is, we cannot take this color. Its adjacent node must have a different color. If it's not colored, we'll give it a different color. So if it's 0, we'll give it 1. If it's not 0, we'll give it 0, right? That is in the case when it's not visited or it's not colored. But if it is visited, if it visited, right, since it's a non-directed graph, it can be visited, right? And if it's not, if it's already visited, then we'll check, hey, if it's visited, what it does, it color, if it's not visited, is the color of the adjacent node is same as the current of the parent node that it came from, or the adjacent node that it came from. If that is the case, we'll immediately return false. That means there's no possibility we can color it differently, and this is not a bipartite graph. And if so, let's say we finish Let me expand this. Right, let's say if we finish all this, all our BFS and everything is colored, and we never entered this if statement, where we find a similar color node already present, then you're gonna say, hey, if we can color all, return true. And if you if you observed in the starting, they say the graph may not be connected. That means there can be some additional uh, element. For example, here if you see, there can be a node like this, an additional node, right, like this. So this is a non-connected component. So that's why in here, when I call my helper, so I'm calling it for every node. So if it's an non-connected disconnected graph, and a node which is disconnected, or a particular segment of the graph, different segment that is not connected with the other segment, then we have to check every component to see if every component is bipartite or not. Even if one component, single component, we find out that it's not bipartite, we're going to return false. If after checking for every component we see, hey, everything is returning true, we return true, that is the whole graph is not bipartite. I've already ran this, and everything works. I've already submitted it. So that is all about the bipartite graph. So basically, whenever you hear bipartite, think of it as graph coloring. We have to color the graph adjacently, such that no adjacent node of a graph has the same color. That is the gist. If you keep this particular point in mind, the bipartite graph seems very easy.